Hello, you're welcome. All right, so now the topic before us is trigonometry. Okay, so now what is trigonometry? Now, trigonometry is actually the branch or the area of mathematics. Okay, the branch of mathematics that studies, that actually studies the relationship between the sides and the angles of a right angle triangle. Okay, so the background of trigonometry deals with the actually this with the relationship between the sides and the angles of a right angle triangle. And as you can see in this diagram, okay, this is a right angle triangle. Okay, and of course, a right angle triangle is a triangle that is constructed when uh, a vertical line and a horizontal line is being joined. Okay, as you can see here. So now, so the relationship that exists, okay, between this sides of this right angle and its angle is what trigonometry is all about. So here in trigonometry, we are going to be looking at trigonometrical functions, okay, or formula. They are the same, all right. The functions that actually establish the relationship, the formula that established the relationship, and the identity that actually establish or even extend the relationship. And then we're going to be looking at all of them one after the other. So let's start by describing the size of a right angle triangle. Okay, so now the size of a right angle triangle, they they have a name, all right. Okay, now the side that is actually opposite to the reference angle. Okay, at each time I'm considering a right angle triangle, I'm considering just an angle. Okay, so my reference angle here is theta, all right? So the side that is opposite to theta because is the opposite. So mind you, if the theta I'm actually considering is not, let's say I'm looking at theta to be here, right? If the theta I'm considering is this, okay, then the opposite is gonna be uh the side that is opposite to it. Okay, so please take note of that. All right, so the side that is opposite to the angle, reference angle, is opposite. And of course, the side that is actually adjacent to it is called the adjacent. And you have the side that is opposite, okay, directly opposite to the angle 90. This is actually is the angle 90. So this side that is opposite to the angle 90 is called the hypotenuse. All right, so now let's start with the relationship. The first relationship is what we call trigonometrical function or ratio. Trigonometrical. Okay, so it's a ratio. Of course, you know what ratio is. Ratio is a fraction. Okay, it's the ratio of the size of two sides. Okay, any two sides of the right angle triangle, and each of those ratios of the size of the right angle triangle has a name. And for us to remember the name, we use the abbreviation. Okay, the abbreviation is SOHCAHTOA. SOHCAHTOA. All right. So now let me actually redraw my right angle triangle, and of course, give it the side. Let's say the angle is still theta, and of course, the longest side, which is the hypotenuse, I'll call it A. All right. Then here, okay. Let me call the adjacent. Let me call the adjacent A. The hypotenuse. Let me call it B, and of course the opposite. Let me call it B. The hypotenuse. I call it C. All right. So this by angle 90. So SOHCAHTOA is the ratio. Now the S here. This is the first ratio. The first ratio is called sine. It's called sine of the angle. Sine of the angle, which of course is sine theta. Okay, from this abbreviation, sine theta is equal to the opposite all of hypotenuse. Okay, so sine theta is opposite divided by the hypotenuse. And of course, opposite of this rectangle triangle is actually B. The hypotenuse is C. Okay, Now the next ratio is cos theta. Cos theta is, as from the abbreviation, adjacent all over hypotenuse. All right, adjacent all over hypotenuse, and of course my adjacent is A and my hypotenuse is C. All right, then the last is the tangent. Okay, this causes the abbreviation of cosine of theta. All right, so the next is the tan, which of course abbreviation to tangent, tan theta. Okay, so the ratio is going to be opposite all over adjacent. Opposite is B, while the adjacent is A. So please take note of this formula, and that is why I have to give you this abbreviation so that I can always remember it. Okay, we are going to use that later on. Now let's now proceed. So the first, this is the first function, right, that I've given you, said the trigonometric ratio. The next function actually deals with the relationship between the sides, the three sides, okay, and we get that by a rule known as Pythagoras rule. Pythagoras rule is actually a formula or a rule, okay, that actually establishes a formula which connects the three sides of a rectangle triangle. So according to Pythagoras rule, the longest side, which of course is which is the hypotenuse, the square of the hypotenuse is equal to the square of the adjacent a square. C square is equal to a square, then of course plus b square. This is Pythagoras rule. Okay, so please take note of this. I'm gonna actually introduce an example so that this will actually make sense. Let's look at example. Okay, all right, given that cos theta is equal to 3 all over 5. Okay, now the question is evaluate A sine theta plus tan theta. B 1 minus sine square theta. All right, so solution. So from what was given, what I have is cos theta of the angle. All right, so since I have cos theta, remember cos theta actually gives me the two sides. Okay, so now I'm here to evaluate and be asked to evaluate sine theta. Okay, and from the information cos theta, how will I be able to get sine theta and tan theta? Why? Okay, it will not be, actually I can't get that because the ratio of cos theta is not the same ratio with sine theta, because cos theta, you know very well that is cos theta is equal to the is adjacent all over hypotenuse. Okay, that is what. So but sine theta is always opposite all over the it's always the opposite, please pardon me, opposite all over hypotenuse. Okay, opposite B all over hypotenuse. All right, so now the question is, already I have what I have here. What I have here is only the hypotenuse from cos theta, which of course is a 5. Okay, so the question is, how do I get the opposite B? How do I get the opposite before I be able to solve this? So don't forget that I can do that. I can get that using Pythagoras rule. Okay. So from Pythagoras rule, you know very well that what we have is the opposite. Okay, the opposite is 5. All right, and of course, the please pardon me. The hypotenuse is 5. C is 5. Hypotenuse is 5, and of course, the adjacent. Okay, the adjacent BA is 3. So the question is, how do we get the opposites? Okay, so let me call the opposite. Of course, the opposites are called B. So by Pythagoras rule, you know very well that 5 square is going to be equal to 3 square, then plus B square. So I can get my B from this now. 5 square is 25. 3 square is 9. Okay, if I'm not mistaken, yeah, I'm not. Then plus B square. So if I want to get B square, I'm going to have 25 minus 9. Okay, so this is going to be, if I'm not mistaken, that should be 16. Okay, am I mistaken? Um, that is, yeah, 16. B square 16. That makes B not to be equal to the square root of 16. Square root of 16 is 4. Okay, so that is my opposite is 4. So that way now, sine theta is equal to B, which is 4, then divided by the hypotenuse, that is 5. 4 over 5. Then, of course, tan theta. Get tan theta from the formula. Tan theta is always adjacent, opposite all over adjacent, TOA, okay? TOA from our abbreviation, TOA, opposite all over adjacent. The opposite, we've already gotten that is 4, divided by the adjacent, which is 3. Okay, so combining the two now, we can now have that sine theta. Okay, sine theta plus tan theta is going to be equal to sine theta is 4 over 5. Tan theta is 4 all over 3. All right, so now let's LCM is 15. 15 divided by 5, I have 3. 3 times 4. Okay, that's going to be 12. 15 divided by 3, I have 4. 4 times 4, that is 16. Okay, so adding up, I'm going to have, this should give me 20. This should give me 28 if I'm not mistaken. 28, okay, all over 15. So I believe 3 will go. 3 go into 28. What do I have? Can 3 go into 28? No, 3 can go into 28. Okay, so basically that's so that should be basically one whole number. Then 13 all over 15. Okay, if I'm not mistaken. If I am, we just correct that. Okay, so now for this 1 all over sine square theta, that's going to be equal to 1 minus, please pardon me, 1 minus sine square theta. So that's going to be 1 equal to 1 minus sine theta, then you square the sine theta. Sine theta is already 4 all over 5. Then I have to square that. Okay, so square. So that's going to be equal to 1 minus 4 square is 16. And of course, 5 square is 25. Okay, so of course, I will simplify. The LCM is 25. 25 divided by 1 is 25. 25 times 1 is 25. Then minus 25 divided by 25. That is 1 times 16. That's 16. So subtracted 25 minus 16. Okay, that should be done all over 25. So, all right. So that is how we actually apply the ratios and, of course, Pythagoras rule to solve such a question. All right. So we are going to proceed. This is just an introduction, okay? So I'm just giving you the foundation of the background of trigonometry. So as we go higher, we actually look at other identities and formula. All right, so now let's actually proceed. Now, the next function we're going to learn is what is known as the inverse trigonometrical function. Inverse trigonometry. All right, we're going to learn the inverse trigonometry. Now, what do I actually mean by inverse trigonometry? Inverse is same as reciprocal, okay? So we have the, okay, inverse, inverse trigonometrical ratio. Let me put that trigonometrical ratio. All right, so now what I mean by inverse is simply the inverse of all the ratio, okay? 1 all over all the ratio I've already given you. There are three ratios that give you sine, cosine, and of course tan. So 1 all over sine is the inverse of sine. And of course, 1 all over sine theta is always equal to cosec. Please take note. So if you are dealing with 1 over sine theta, it's an inverse, which is called cosec of theta. If you are dealing with 1 all over cos theta, this is the inverse of cos theta, which we actually refer to as sec theta. Then the last but not the least, if we are dealing with 1 all over the tangent of theta, okay, that is called cot theta. So please take note of that. This called cot theta, okay? So this is inverse trigonometry. So we actually found this handy as we actually look at trigonometrical identities, all right? So, all right, I think I'm going to give you the time to go through this first. Go through this that as you come, as we actually start with the new video, we are going to look at trigonometrical identities, all right? So see you in the next video. Thank you very much.